everyone, welcome back to another note set. All right, let's get started. This is about acceleration. So here we go. All right, acceleration is another way to measure and describe the motion of an object. So it's a lowercase a. We call it a rate of change of velocity over time. So it's when an object is considered to be accelerating when it speeds up, slows down, or changes direction. We can measure this in miles per hour squared, meters per second squared, or kilometers per hour squared. Don't forget that squared. That's very important. We can have a positive acceleration. It's when an object speeds up. We can have a negative acceleration. It's when an object slows down. And this is the equation we'll be using. A is equal to VF minus VI divided by time. VF is your final velocity and VI is your initial velocity. All right, let's go ahead and go over an example. So a car is traveling 35 kilometers per hour and it accelerates to a speed of 45 kilometers per hour in 0.25 hours. What is its acceleration? So we have our VI, which is our initial velocity of 35 kilometers per hour. Our VF, which is our final velocity, is 45 kilometers per hour. Our time is 0.25 hours, and we're looking for acceleration. So we're going to be using our normal equation. So 45 minus 35 over 0.25. As you'll notice, the top part is in parentheses. Parentheses comes first in our order of operations. So 45 minus 35 is 10, so 10 kilometers per hour divided by 0.25 hours. And our answer is 40 kilometers per hour squared. So example number 2, a jet is traveling at 80 meters per second when it starts to approach a runway. It is able to land and park in 10 seconds. What is its acceleration? So our VI is 80 meters per second. Our VF is 0 because it comes to a stop. Our time is 10 seconds, so we're looking for acceleration. So we're going to use our normal equation once again. So 0 minus 80 divided by 10. Again, notice that this top part is in parentheses. Yes, we can have a negative acceleration because that means we are slowing down. So negative 80 meters per second divided by 10 gives us negative 8 meters per second squared, meaning that it was coming to a stop. It was slowing down. And again, the negative acceleration makes sense because the jet is slowing down as it comes to a stop. Example number 3, a skateboarder has an acceleration of 1.5 meters per second squared. Starting from rest, if it accelerates for 2 seconds, what speed will it reach? Or will he reach? So our acceleration here is 1.5 meters per second squared. Our VI is 0 meters per second, and our time is 2 seconds. So we're actually going to be solving for VF in this example here. So our initial equation is this one. We're going to multiply each side by time to get rid of time on the bottom here. So we have AT equals VF minus VI. So in order to get VF by itself on one side, we have to take or add VI on both sides. So our final equation is AT plus VI equals VF. So we're going to go ahead and plug and chug that in. So 1.5 times 2 plus 0, so 3 plus 0 gives us 3 meters per second for our VF. So I'm going to go ahead and have you pause, try to solve these as best as you can, and come back for the answers. All right, for number 1, our answer is 6 kilometers per second squared. For number 2, our answer is 3,614.5 miles per hour squared. And for number 3, our answer is minus 1.23 meters per second squared. And for number 4, our VF is 65 miles per hour. All right, we can also graph acceleration. Remember that graphs can visually help us to understand an object's motion. So remember that slope is the steepness of a line. It's calculated as rise over run equals delta y over delta x. On a velocity versus time graph, this means that when we calculate, rise over run or delta y over delta x, that's velocity over time. So on a velocity versus time graph, the slope is your acceleration. So make sure we're paying attention to these graphs, the names of the graphs that'll tell you the difference between distance versus time and velocity versus time, because you are about to see some similar ones. All right, so for graphing acceleration, we have these 4 graphs. We're going to start with this blue one here. This means that the object is not moving, therefore it has 0 acceleration. This one, this object is moving at a constant speed, therefore it has a 0 acceleration. This one right here, the object is speeding up, therefore it has a positive acceleration. And this one right here, the object is slowing down, therefore it has a negative acceleration. We also have a few other graphs here that can help us with distance versus time. So this one right here, the object is not moving, therefore it has 0 acceleration. Same thing, the object is moving at a constant speed, therefore it has a 0 acceleration. And this one right here, the object is speeding up, therefore it has a positive acceleration. And here, the object is slowing down, therefore it has a negative acceleration. And we have seen these 3 graphs before as distance versus time, I guess, as well as this one, but now we're using it to describe acceleration. So you can use distance versus time graphs to describe acceleration. All right, if you guys have any questions, let me know.